Hopefully Lauren will be able to join us soon. All right, sorry about that, man. I just was waiting for everyone to kind of get back with us. And every week I spell your name wrong. I don't know why I keep putting W-I-N instead of W-E-N. I'm sorry.
That's okay.
As long as you get credit, right? That's all that matters. Okay, so we're just going to start with number 3. We kind of talked about that this one just seemed like we're just paralleling the two variables, and the difference being that they aren't connected in any way. So we're just going to take a stab at this and see if we can just get it done. So number 3, what requirements must be checked when conducting a hypothesis test comparing two means with independent samples? Mark all that apply. Random sample is like always has to be, and normally distributed.
Mm-hmm. Did we start the broadcast?
Yes,
okay,
it's going. So yeah, we just missed the first part. That's okay.
Okay.
It's going now, and so that's what's important. Test statistics for a hypothesis test comparing two means with independent samples is a fantastic score. No, I'm just kidding. Still, it's t-score because we still don't have a.
I think it's t-score.
We don't have a known. What is that standard deviation?
Hey.
Is that Lauren? No, not yet. Maybe almost. Maybe.
Two samples.
Okay, number 5. Two samples are independent if knowing which subjects will be in group 1 determines which no, it's the bottom one.
Mm-hmm.
Nothing. Okay, information for the next 6 questions. Use data file. Here's all our information. What is the degrees of freedom? Well, I guess I have to open up the dentist bill to see how many things are in there. In the dentist bill.
What do you guys get for number 3 again?
The first 2, a simple random sample is drawn from each population and mean is normally distributed for each group.
Okay, thanks.
Mm-hmm.
What'd you get for 5?
The second one, knowing which subjects will be in group 1.
Okay.
Nothing. Okay.
Well, I'm an idiot. I just tried to paste something and I was trying to copy it.
This data represents a simple random sample of dental bills at a dentist office in Idaho Falls.
Sorry, I'm still waiting for it to reload. I'm really stupid. All right, I want to copy, not paste. All right. And I'm going to go stick it in number 1. Okay.
Can you show me your screen what you're doing? Because I'm.
Yeah. So.
Okay, so you have the data there. That's what I have, the dentist one.
So I'm taking the data of this one.
Uh-huh.
And then I am, my mouse. Then I'm pulling up this inference thing right here.
Okay.
Plugged in the first column into the first stack right here.
Okay.
And now I'm going to go over here and I'm going to take this second column.
And put it in the.
Yeah, and just copy it. And I'm going to go back in here, pull it up all the way, and stick it in this one.
Okay, and then you get all the necessary.
Yeah. What I have down here is some extra garbage, probably from earlier, from when I was doing the lesson part. And I need to get rid of this right here. I should just reopened a new one. Okay, so then we're going to go over here. So what was the question again? No, I forgot the question. What is the question for number 6?
What is the degrees of freedom?
Okay, so it looks like this degree of freedom is 37.996.
37.99.
Hold on, are they the same? Oh, I guess they are 20. Okay, never mind. Because the examples were different. Okay, 39. I say 996.
37.996 or 39.996?
What else? Okay, so it's 37.996. So also, no, 37, sorry. 37 and 13 answer. So 37.996.
Mm-hmm.
Question number 7. What is the standard deviation for Rexburg? I don't know. Which one is Rexburg? Okay, so Rexburg is variable number 2. So variable number 2, the standard deviation is 206.637. So I have no idea if this is right, but I'm just going off of it. But I put the information in right. Only 80% right decided. 80% right. All right, what is the test statistic? That's going to be P. And so I have negative 0.434.
That's what I got.
Okay, and then number 9, the p-value.
What's 8? I'm sorry.
8 is negative 0. So,
0.43.
yeah.
434.
434.
Okay, sweet. Thank you.
And number 9, I used this thing correctly, it's 0. Let's round it. So, 6.7. The correct is based on evidence. Wait, what were we supposed to put our, oh, yes, this is 95. We need to have this at 99.
Wait, what's
The rest of that's still right. We still have it right.
number 8?
So number 8, I put, let's see, 8. So number 8, 0.4.
I cannot hear you clear.
Oh, I'm sorry. Negative 0.434.
Negative 0.434?
Yeah.
Yeah.
The t-score.
And for question 7 is 0.434?
So for question 7,
Oh,
so question 7, when it says a test statistic, is talking about t-score. So that's where I got was this t-score right here. And I go down to 9. I'm looking at this p-value that gave me 0.6665, and I rounded it up to 0.7.
For 10, we're gonna, let's see, what is the correct decision based on the evidence? Wouldn't it be fail to reject?
Fails to reject. They put it all on correctly. And it's instead that you do the alternative. That's not equal. Mine is less. Our p-value actually is not correct.
Which number?
So
The p-value?
variant is not correct. Because I didn't change this one up here to less than. And it still is not equal. I haven't changed that one. So when I change it to less than for the instructions, it's actually doesn't change our next number. It's 0.333. And then we are still going to false reject it. Now we're going to change it to this don't equal. So then I'm going to go back up here and not equal to. Then make it 0.6. So we have sufficient evidence. Okay, I think it's the second one.
I don't know if it's my speaker, but I can't really hear you, Cinnamon.
You know what? Let me go grab a. I'll be right back. Let me just go grab a headset.
Okay.
So what's number 9 again?
I couldn't really hear her either. I think it might be 0.333. I'm still having trouble like navigating around the Excel.
Okay.
But I could be wrong. I don't know. We should ask.
Yeah, it said 0.333.
Okay.
And what's like for 7? I didn't hear her.
206.637, right?
206.637.
Mm-hmm.
Okay, thanks.
So what number are we on now?
Okay, it's because I have my computer turned away. So if we're on number, where are we at? Number 11, I would say we still don't have enough. We have insufficient evidence that the mean of the dentist bills between the two cities are different. We can't throw out the null hypothesis.
Okay.
I thought it was the second one.
That's what I have.
Okay.
The second one. Okay, so freshman diner data. We want to make sure we set this to 0.95. And what does it want to do? Okay, this data represents number of freshmen. The mean number of times a student a month from Colorado cooks dinner and Utah cooks dinner. Freshman from Colorado, 0.5 tests, is this correct? Okay, so I guess we're just looking to see, like, are they equal? Not equal? What it sounds like.
What is the appropriate alternative hypothesis? So if that equals
Let me get rid of this data right here. Put in the new data. Okay, so Colorado's supposed to be first.
mm-hmm.
And it's supposed to be 7. Okay. All right, so I have a standard deviation or confidence level 0.95, and I have it not equal to, and make sure we have, okay, so the appropriate alternative hypothesis, what do you guys think?
Is it the middle?
I think it's the middle one. I think it's the middle
so.
one.
Yeah.
Okay.
What is the statistic test? So I still have negative 0.845 in the spreadsheet, and p-value of 0.411.
0.1.
0.411.
Okay.
And then that would be reject the null?
No, because it's still greater than 0.5, because it's 0.4. So we're still going to fail to reject it.
Okay.
All right. Determine 95% confident intervals for these two, and estimate or the difference between 1 and 2, and input your answers below. What? Determine a confidence level. Okay, confidence level for 1 minus 2. What the heck? Okay, this has to be doable.
Determine the margin of error.
I feel like I have to go and plug this into, if this is the mean,
Do we?
the standard deviation is 4 point. Right? Because if you have 15 and when we subtract the margin, wouldn't we subtract the standard deviation between the two? Wait, 0 to junk.
I think so. From the mean? Or from what?
I don't know.
Let's see.
I don't remember this part in the lesson.
It can be.
Okay, so I'm going to go to 17 and 18 because that looks easier. 17 is put in the lower bound, which is negative 5.147. And I'm going to go to 18, which says input the upper bound, which is 2.214. Okay, so when I tried to find the margin of error before with the other ones, all I did was subtract the mean from the highest confident level. Like I took the highest confident level and I subtracted the mean. And that told me what that chunk of between. I guess I don't understand. Oh, two simple tests. No, that's right. We're in the right spot. What would be I don't understand why this information is only one chunk of information down here, where this is a two chunks of information up here. So would I go, yeah, I have no idea what to do on this one.
Determine the margin of error for this 95% confidence interval. So,
What'd you say 17 was?
So 17 is asking for the lower bound, which was negative 5.147.
147?
147.
Okay.
And then the upper was 2.214.
2.2. Yeah, I got that.
Okay.
and the margin of error. It can be calculated as a multiple of the standard error with the factor depending on the level of confidence desired. The margin of one standard error gives a 68% confidence interval, while the estimate plus or minus 1.96 standard errors is a 95% confidence interval.
Okay. Remember, we would never assume equal variances in this course. Two different confident intervals are possible, depending on how you define the price. Okay, so we are still going to take these same confidence levels, as this is what I'm getting. And we're subtracting the mean of each one. So if we take 2.214 and we subtract, let's say, variable number 1 of 15.200, that can be right, because the mean, I'm going to put in the negative. I don't know. Okay, let me go back up here again. Try to figure this out. Verify requirements and find that. Remember, we will never assume equal variances in this course.
Find what's sample size and the sample proportion. Sample size. All
right, this is, I know it can't be this hard. It's got to be easy.
Well, I just like multiply the sample proportion by 1.
I don't know. What do you guys think, Ben, Laura? Lauren, what do you? That's the only one I don't know how to do, and I know it's going to be super easy.
Find the margin of error with dot and
I'm trying to figure it out right now.
Okay. Okay, the order in which we subtract the means determines the sign of the results. If we subtract, well, let's look at that homework. Wait. So let's go. I'm gonna go look and see if there was the one that was like this on the homework. I don't remember, but I've had a rough day. My tummy. All right, so if we go to content, go to 7. I'm gonna go see if I can find something really quick. because at least we'd have the answer if my word would open. Okay, let's see which one it is. Okay, so if we go to number 6H, and we go to the, okay, we have insufficient evidence to say that. Okay, we would create a 95% confident interval using the t-distribution, depending on the difference calculated. Okay, so what about if we're subtracting the t-distribution from the mean?
The t distribution from the mean.
Yeah, so the answer to, so if I look at the test or the homework question, number 6I, and then I go look at, so 6I or H, it says, rather than testing a hypothesis, now, say you just wanted to estimate the difference between female and male wages at 95% confident level, create a confident interval to estimate this difference. Then present your conclusions. So then when I go to the answer sheet and I open it up and it says, we would create a 95% confident interval using the t-distribution of -0, blah, 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 plus. So it's either reversed. Let's look at that on the hospital one too. Go back to that. It just almost looks like they're the reversal. They can't be the reversal of each other. This makes no sense to me.
Yeah, I'm lost.
I don't remember this. So,
Why is it? So if I look on number 22, right before the summary, if you look at it, it's the interval, they're reversed. So -158, and then the other one, they reverse places, and now it's a +158. And the other one was 24.0, and then the bottom one, it's reverse positions, and it's -24.0. Like they swap their places in the parentheses, and then swap their sign, their positive and negative sign. How we interpret that is that we are 90% confident that the true mean difference in the I have no idea what that meant. I have no idea. All right.
should we just
We do what all good students do. You text your TA. No, just kidding. Which number is that? Number 16?
Yeah.
Okay. Because we've tried. We read the lesson, we've gone back over the homework, and it didn't make much sense to me when I was trying to do it. I was just believing the homework key. Okay, we're stumbling on number 16.
I'll be right back.
Okay. If I get an answer back and you guys need to go, then I will let you know what he says.
Okay, sounds good.
Yeah, I just have to leave by 8, so I'm good for about 10 minutes.
Okay. Okay, information. Okay. Oh,
I feel like they get harder as they go on.
I know. And we're only halfway through today. I was like sitting thinking, oh my gosh, we're only halfway through.
Yeah.
We still have another half to get even harder. And the homework. Okay.
Well, the good news is that we got all of them right, except for that one.
Well, that's good news.
Yep.
That means we're on the right track. We just don't know what this one is. It appears the difference between. I just don't get this one. Okay. Find the confidence interval. Remember, we want to assume two courses. There's confidence interval. So the true mean difference. So what's our question again? Determine the margin of error. What is it that gets us to these 2 points? I guess is the question. Where's the calculator at? Don't know how to fix this. It has these on the wall and I can't. Okay, so here's my guess. This is what I did. This is my total guess, and I'm going to put it in, and I'll let you know. I took negative 5.147, subtracted 2.214, and I got that negative 7.361, right? So I got this chunk of space between the two. And now I'm going to divide it in half by 2, and it gives me negative 3.680. So that's what I'm going to do. And I'll let you know if I'm even close, which I'm sure I'm not, but that's the only thing I can figure out. It's something super easy, but I have no idea what it is. And I'll probably respond later. Okay, I'm just going to submit it and see what it is.
Did you guys put an answer for it?
Huh?
Did you guys put an answer for it?
I'm going to throw an answer in. I'll let you know if it's right or wrong, since it's my stab in the dark. Save you guys.
I'm gonna leave it blank. I don't know.
It won't let you submit unless you put something, though. That's the dumb part.
Okay.
It does.
Does it? Because I
Yeah.
clicked it the other day. It was like, you didn't do number 7. And I was like, oh, all right, well, I'll go do number 7 then.
Warnings, you have one answered question. Submit.
Oh, I guess you can. Okay. Well, okay. The good news is that we really did get everything right, but I still got Number 16 wrong. It says your answer is slightly lower than in Excel. So the answer given is the average between the two results. You should be close. Your result should be close to the answer shown. I don't know what that means. Anyway, so 16
Yeah.
I haven't a freaking clue.
We'll hear back from
I'll let you know what he says.
Okay. Thank you.
So, but hey, 95% is better than, 60.
yeah.
Yeah.
Like one of my other quizzes that we did as a group, and I was like, oh, well, that sucks. Okay. Let's meet on Tuesday since it's almost 8 o'clock and you guys need to go. So I'll let you know what he says when I hear back from him, okay?
Sounds good. Thank
Okay.
you.
Have a good
Bye.
night.
Bye.
Bye.